Good day, everyone. All right, so in this video, I want to talk about question 8A from the 22-23 paper for semester 2 of the Malaysian Matriculation certificate. Okay, so let's look at the question at hand. The mass of helium nucleus is 4.001510 U, or AMU, atomic mass unit. Calculate the binding energy of the helium nucleus in MeV. Okay, so let's start, right? In order for us to calculate the binding energy, we need the mass defect. The mass defect is simply, the mass defect is simply the difference between the atomic constituents, right, minus the mass of the nucleus. So what constitutes a nucleus? You have your proton, so that's just the number of proton times the mass of the proton plus the number of neutron times the mass of the neutron. So because they gave us in AMU, we should have these in AMU as well. That will just make our lives easier. Okay, so if we look at the problem at hand, we'll have 2 protons and 2 neutrons, right? So I'm just going to substitute the values for that. We have 2 protons times 1.007277. That is the mass of the proton in AMU. And then we have our number of neutrons times the mass of those neutrons, so it's going to be 1.008665. That's the mass of the neutron. Okay, so the sum of that, the total of that, minus what you have here, which is the mass of the nucleus, which is 4.001510. Okay, and then what we'll find is the mass defect, or just the difference in masses. Okay, so that's going to be 0.030. Wait, what was that? Okay, so 0.030,374. In general, I highly recommend having 6 decimal points. Okay, U. Don't forget the unit, it's U. Okay, AMU. And then from there, I can calculate the binding energy. I can convert into MeV, so I'll have 0.030374 times 91.5 over c square MeV. Okay, so the c square just cancels out. And what I'm left with is the binding energy. So key that into your calculator and you will find that the binding energy is 28.29 MeV. So what did we learn here? You see, for questions that ask for binding energy, you might want to consider calculating the mass defect first. Once you have calculated mass defect, and then you substitute it into calculations for the binding energy. Now, there are 2 approaches for this particular question. You can do it in AMU, which is atomic mass unit, or you can do it in SI unit, so kilograms, and speed of light, so ms-1. Okay, you can do either in AMU or kg meters per second. If you were to do it in MU, then you will need this conversion. Okay, if you were to do it in kg and meters per second, then C, this particular part, C is just 3 times 10 power of 8 meters per second. Okay, all right, so that is all from me. Thank you very much.